Okay, in this video we're going to be talking about the reciprocal function family. So it's going to be equations that look like this, where it's just an x sitting on the bottom. We're going to have, here's our family form right here that we're going to be shifting. So h and k will represent certain numbers when we're graphing. So an example of this is going to be graphs that are going to shoot off like this and like this. So it's going to be like mirrors of each other in a sense. So our first example, we got 8 over x, where x cannot equal 0. The reason x cannot equal 0 is because anytime I have 0 on the bottom of my fraction, it's going to give me an error, which is why we have these U shapes, because we're going to have asymptotes that are going to occur where we're going to get errors because our lines can't cross there because it'd be a 0 on our graph. Okay, so if I was just doing generic, me plugging in and finding our y values, 8 divided by negative 4 would get me negative 2. This would get me negative 2.66. 8 divided by negative 2 is negative 4. 8 divided by negative 1, negative 8. 8, 4, and then 2.66. So if I were to graph it, remember you go left or right and then up or down. So I'd go left 4, down 2. I would go left 3, down 2.6. I would go left 2, down 4. And then I would go left 1, down 8. So he's kind of like this and shoots off like this. The reason we're not crossing that 0 is because it would give me a 0 on the bottom, which is an error, okay? If I do my next set, I go right 1, up 8. My next one is right 2, up 4. My last one, right 3, up 2.6. So he's going to come down like this. So that's kind of what our generic graphs will look like that we can type into our calculators. Okay, so just comparing the graphs, how do the graphs compare? So my A, so this is going to be y equals 6 over x. This would be y equals 0.25 over x, and y equals negative 6 over x. If you were to plug these in your graphing calculators, it's a lot easier to visually see. This 6 right here, if my parent function is 1 over x, if I'm multiplying by 6, it's actually going to stretch at 6 because it's bigger than 1, which means on our picture it's going to look like it's getting farther away from our axes. This 0.25 is smaller than 1, so it's going to compress by 0.25. In our graph, it's going to look a lot like it's getting closer and closer to the axes, so they look a little weird. This one, we have a 6, so I know it's going to stretch. And then this negative here is going to be my reflection over my x-axis. Okay, it could be attached to the 6, it could be sitting out in front of your whole fraction, or it could be attached to the x, but it will always be a reflection over your x-axis, and it's going to kind of look like a mirror image of our original. Okay, so our translations here from our parent function, if my number on top or in front is bigger than 1, it's going to stretch. If it's between 0 and 1, it's going to compress or get smaller. It's going to reflect if it's negative. H value and k value. So k value is going to be moving my graph up or down. Down. And then this is going to be my left or right, and it's always the opposite of what you think. And then we're going to throw asymptotes in here. Okay, so this is a big thing to remember with these ones. So horizontally, it's left or right, so it's going to be y equals whatever your k value is. Your vertical is going to be x equals whatever your h is. So that's the key with these ones, is remembering y equals and x equals what letters. Okay, so my first one, if I think back here, horizontal was y equals, so I'm going to say HA for short, for horizontal asymptote, and vertical. So it was y equals k, and then this is x equals h. Okay, this is my h, that's my k. So my k value, I got y equals negative 2. My h value is the opposite of what we think, so x equals negative 1. So whenever I have a y equals graph, horizontal is like the horizon, so it's going to be my dashed line that's going to go this way because it's an asymptote that we're not going to cross. So y equals negative 2, it's going to look something like this. And then I also have x equals negative 1. Vertical, remember, is up or down, that's why it's x equals. And then it's at negative 1, so it's going to be like this. Okay, then I'm going to put all of this in my calculator. Make sure when you put it in your calculator you put this in parentheses so that they're both on the bottom of your fraction. When you graph it, if you type in second and graph, you'll be able to see the table values. Okay, so if I'm trying to figure out the right side, I know that this is not going to work right here, this spot. So I'm going to try looking at 0. It looks like 0 hits at -1. And remember, you're always going from your origin, not from your dashed lines. Okay, if I go from there, 1 at -1.5, so I go right 1 down 1.5. So it's going to look something like this if I looked at my graph. My next one, I'm going to start it at -2 because that's where it starts inserting into this left side here. So if I look at -2, it's -2, -3. If I bump one more over to the left, I could do -3, which is -2.5. So I'd go left 3, down 2.5. So you want to kind of pick points that are to the left and to the right of your asymptotes so that you can get actual values in there that aren't going to be super scary. So that's kind of what your graph's going to look like. Okay, so I'm going to add domain and range onto this. So first off, the transformations. This -2, remember if it's on the outside, it's going to be up or down, so down 2. This +3 is the opposite of what you think, so it's going to be left 3. So my whole graph is going to shift left 3, as well as my asymptotes here. So I have my horizontal asymptotes and also my vertical asymptotes. If I look back, horizontal was y equals k. This was x equals h. Okay, and this is my h, my k. So my horizontal asymptote is going to be y equals -2. My vertical asymptote is going to be x equals the opposite of what you think, so -3. So at y equals -2, we got our dashed line. X equals -3, we have our dashed line. Okay, and then we need to do our table to get more points, so I'm going to do that super fast to get our graph in here, and then I'll explain the domain and range. Okay, when I look at domain and range, remember that domain is always my x values, range is on my y values. Okay, so x values, I'm going left to right, so if I pick a different color here, I'm going to start with -infinity because I'm coming from the left side, and then I hit the wall because that's my asymptote. My asymptote's at -3. Okay, so I go to -3 and then I start back up again after that -3 and I go to positive infinity. Okay, so that's going to be my domain because I start at -infinity, I hit the wall at -3, so I need to include all those values in between -infinity and -3, but I cannot include -3 because there's a wall there. I don't have a line there. Okay, it's going to work the same as with range, but range this time is top to bottom because we're talking about y's. So I still start with -infinity. I'm coming up from the bottom right here. I hit the wall at -2. I start back up after -2. And I keep going up, 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 and I'm going to positive infinity. So that's what your domain and range are going to look like. Okay, the next one here, translations, it looks like that +1 is going to tell me up 1. That 2 is going to tell me I'm stretching. And the negative is telling me I'm going to have that reflection over the x. Okay, so I got horizontal asymptotes and vertical asymptotes. So looking back, horizontal, I got y equals k, x equals h, so h and k. So I got y equals 1. My h right now, I could add a +0 here and not change it at all. So x equals 0 is actually my vertical asymptote. So at y equals 1, there, and then x equals 0, so we're like kind of on our main line here. Okay, I'm going to type it in my graphing calculator and get our generic graph, so I'm going to pause this. Okay, so my graph should look something like this. First off, I looked at -1 because that's to the left of my asymptote, got that one, and then I also did -2. The right side, I did 1 because it's to the right of my asymptote, and got that point and also did 2. So domain is my x values, so my left to right. So if I'm starting from the left side here, I'm going from -infinity, and I'm hitting the wall at 0. I start back up at that 0, and then I continue on to positive infinity. Okay, range is going top to bottom, so I'm starting it at -infinity, and I'm hitting my wall at +1 this time. starting back up at positive 1, and I'm continuing on. Oops, these are supposed to be y's. And I'm continuing on to positive infinity because I don't hit any more walls. Okay, a good way to look at it is whatever your horizontal asymptote is, that y equals, is what that number is that's going to divide it. Whatever your vertical asymptote is, so that x equals, is what's going to divide your domain as well. Okay, my next one, that minus 3 means I'm going to be shifting it down 3. I got horizontal and vertical. So my h is going to be 0, and then here's my k. So my horizontal asymptote again was y equals k, x equals h. So y equals negative 3, and then x equals 0. So y equals negative 3, x equals 0. I'm going to pause the video so I can get my generic graph. So I'm going to pick the points negative 1 because that's the left of my asymptote, and negative 2, and then I'm also going to pick 1 and 2. Okay, so it should look something like this. So domain is on my x value, so if I start from the left, I go from negative infinity, I hit a wall at 0, I continue after that 0 and go to positive infinity. Range is starting from the bottom, so negative infinity. I hit a wall at negative 3, start back up at negative 3, and go up to positive infinity. Okay, so my last one here, that minus 1, I'm going to go down 1. That 2, I'm going to stretch. And then that 6, I'm going to go left 6. Asymptotes, I got horizontal, vertical, y equals k, x equals h, h, k. So my horizontal asymptote is going to be y equals negative 1. My vertical is going to be x equals negative 6. So my horizontal, y equals negative 1, x equals negative 6. 1, 2, 3, 4, 5, 6. Ooh. Come on. Okay, so I'm going to have to pick a lot of negative values to get my graph this time, so I'm going to pause it. Also make sure your x plus 6 is in parentheses on the bottom there when you're graphing it to make sure that the 6 is down there with it. Okay, so your graph should look something like that. So if I do my domain, so left to right, I go from negative infinity, I hit a wall this time at negative 6, start back up at negative 6, go to positive infinity. My range, I go top to bottom. So negative infinity, I hit a wall this time at negative 1, start back up at negative 1, and go to positive infinity.